Are we gonna do that one last time?
It's warm. Don't do it.
Okay.
Come into my arm.
Milk, chug.
Do it. You won't.
Chug it.
Well, there's one that tastes warm.
It is pretty warm.
Chug it.
Wait, Josh, try this.
I'm going to hide the truth.
Yeah, so it's
Bro, it's nasty. Whoever said they wanted to try this.
No.
yeah.
I have a bird allergy.
Bird allergy. You guys have bird box?
All right. We have to keep this door shut.
Just the God knows podcast.
All right, let's get started as soon as possible because we have a lot to get through. A lot of these problems you'll notice are similar to homework because spoilers, especially for my new kids that don't realize this, all the teachers take the homework and they put it on the review guide, and they take the review guide and put it on the quiz. Now they cut out problems along the way and they change the numbers, right? They don't make you do all of the problems you've ever done in your homework, right? But in general, they're going to look the same. That's the point. So the quiz will not have a problem on it that is not one of these. Will the numbers be different? Oh yeah, they do, right? Will the words be a little bit different? Some, right? Instead of talking about, Lexi going and running around, maybe I'll talk about Anne, right? But like, yeah, in general, it'll be the same. Okay, instead of cupcakes, maybe we'll have chicken nuggets.
Bird allergy.
Chicken and bits.
Here you go.
Does it count? Like, we have a test
Tomorrow.
does it count?
Oh yeah. New kids, especially you, but old kids too, because you guys don't pay attention. You're freaking morons, right? With that kid, right? So,
Yeah.
my policy is, since we have a quiz basically every week, if you've missed at least one day during the week, you don't have to take the quiz. Now, you might think, I'll just miss one day every week, right? But here's the deal. You do have to take it eventually. Also, if you do take the quiz and you've missed, just write that you were absent, and any points you get right, you never have to do again. So there's no downside to taking it. So pretend you were gone 3 days out of the 5. You're probably screwed on that quiz, right? But anything you get right, you never have to do again. You got to sit in class anyway that day, right? Might as well get some done.
Wait,
So just write absent, and I'll know not to put in the grade book. And anything you got right when you're ready to finish it, right? You won't have to do it again. So there's no downside to taking it. Nevertheless, there are always students that are like, oh, I was absent, I don't want to take it. Okay, whatever. I mean, can't hurt, but fair enough. So here's your review guide. She's thick, she got a lot of problems. But again, my homework, I take all the problems on the homework and I cut them down to make the review guide. But I like to give you lots of examples, right? Because everybody loves examples. Practice. Examples. And then I take the review guide and I cut out a bunch of questions, and that's what the test is, right? So in theory, by the time you get to the final, you'll have seen the questions on the homework, on the review guide for the quiz, on the quiz, on the review guide for the test, on the test. And by the time you get to the final, you'll have seen it on the review guide for the final. So you'll have seen that question 6 times before you see it on the final, right? I think it's pretty fair.
and we still get a bunch of free points.
And you do get 3 points, yes. Yeah, we'll talk about that later. We don't have time. All right. Here we go. Again, I would encourage you not to copy stuff down. I would encourage you instead to think about what's going on and make sure you understand it, okay? If you want at the end, I can even give you this, because I'm writing everything. Or you can take these credits.
It's pretty dope.
Okay? I'll make copies.
Really?
Make copies.
Yeah.
Make copies.
Why is school design where it's like you have to take notes? If you don't, you're a bad kid. Like, why not just make it easy on them and give them? I don't know.
Because they're not working.
Right?
Why? Stupid.
The only reason they make you write notes in college is because those notes are usually PowerPoints, and those PowerPoints they paid for and they're trademarked, and so they can't just hand them out to people, which is also stupid, right? So capitalism once again, right? Anyway,
Failure.
if Bo can make 8 cakes in 2 hours, so that's a ratio, 8 cakes.
I solved this. We solved
Yeah, they're very similar.
Mitchell. Such a trap.
2 hours. How many cakes can you make in 5 hours? So we're asking X cakes in 5 hours. Now, you'll notice by my color scheme that they're the same units, which means they're the same on top and bottom. Can't we just set them equal?
Yep.
Yeah. No work to be done. They're a proportion. A ratio equaling a ratio is a proportion. Now, how do we solve proportion? How do we solve a problem like Maria? Multiply by 5 hours to both sides. Now, I'm showing all of my work to show you that when I multiply by 5 hours, something magic happens. All of that goes away because it's exactly the same, right? Divide by 5 hours times by 5 hours, it's just 1, right? We get X cakes, which is what we wanted. So good move, right? Yeah. And over here, hours and hours goes away because hours divided by hours is 1. Anything divided by itself is 1. Anything times 1 is just itself. So it basically just goes away, right? It doesn't become 0 because timesing by 0 would be bad, right? Yeah. It becomes 1. So now we have 5 times 1, which is just 5, times 8 cakes. What's 5 times 8 cakes? 40 cakes. That checks out. 8 cakes in 2 hours, 40 cakes in 5 hours. Yeah, sure. Why not? Do you disagree?
So I guess in the bottom.
Sorry.
8 cakes in 2 hours, 40 cakes in 5 hours. Totally makes sense, right?
No.
No,
It doesn't. What do we forget to do?
Divide by
Divide by 2. The 2's still down there. Just because the hours goes away doesn't mean the 2 goes away, right? So now we have to divide by 2. It's going to be 20. Now that makes more sense, right?
What should we do?
Welcome to my class. I make mistakes on purpose, and I wait for you to catch me on them.
Yeah.
When you get to calculus, I don't teach calculus here, but when I did in the past, we do an entire problem, like an entire board, and they'd assume something wrong. I'd be like, oh, okay, sure. What do you say, right? I wouldn't say it like that. We get to the end, they go, and the ladder is falling at negative 15 feet. Negative 15 feet. It's negative 15. We're wrong. Doesn't make any sense. It does not make any sense. And they go, where do we screw up? And we have this giant board of all these things I could have done wrong.
Might be the last.
And I laugh. Actually think about what you're doing. Don't just go on autopilot. Number 2.
So we spent a whole day.
If
trying to
3
figure
chicken
one out.
nuggets cost 69 cents, what is the cost of 44 chicken nuggets? All right, 3 nuggets.
3 nugs.
My cursor isn't very good. We're gonna avoid it.
You got fake.
69 dollars.
69 cents.
Cost of 44 chicken nuggets. So cost is dollars, right?
Fully 20.
All right, so we can set them equal because same units, right? And now we solve. Uh-oh, x is on the bottom. How do we solve a problem like Maria? Well, we can flip them both. Again, as long as you do both sides, it's fine, right? Proportions don't care about what's on top and what's on bottom as long as the units match, right? So you can do that, or we can times by x and move everything else over.
Whatever floats your boat.
Let's be crazy. Instead of flipping them both and just timesing by 44 nuggets and having it basically be the same problem as this, I'm gonna do this. I'm gonna times by x dollars to both sides. When I do that, this moves over to here. Dollars and dollars cancels, but x and 0.69 stay. So I have 3 nuggets times x in the top, and then 0.69 in the bottom equals 44 nuggets. I'm doing this the hard way, guys, just so you're aware, right? Now how do I get rid of this? I times by 0.69, and then I divide by 3 nuggets. Nuggets and nuggets will cancel, and we're good to go. So I'm going to do 44 divided by 0.69, and then, times 0.69, and then divide by 3. And that's going to be x, nuggets.
No.
So, how did I get there and what happened, right? I times by 6.69 to this side, now it's over there. It had no unit, right?
Yes.
44 had a unit though. Nuggets.
Nuggets. No.
Then I divided by 3 nuggets, and now it's here. All together I get my answer. It's going to be some gross thing, but I'm going to circle it. Because 44 times 0.69 divided by 3, and nobody got time for that.
I'm a gross thing.
3.
$10.12.
1 box can hold 48 cupcakes, and 2 cups of flour needed to make 5 cupcakes. Those are ratios. So we have 48 cupcakes. I'm going to call them cakes for short. 1 box. 2 cups of flour for 5 cupcakes. So 5 cakes. 2 cups of flour, right? How many cups of flour are required to make 3 boxes? So there's all our stuff. This is our end goal, so I'm just going to write that at the end, right? What do you want to start with? Well, we want to start with cups, and we want to start with something that either has cups or boxes in the right spot. Let's start here. 48 cakes, 1 box. Right? Let me zoom out a little bit. I think you guys can see this, right?
Big box.
So we want to keep boxes, but we want to get rid of cakes, right? So I'm going to times by cakes in the bottom because that divides out cakes. And then I'd like to get cups in the top. So I'd like to put cups up top. Do I have something that relates cups and cakes? If not, I got to do an extra step. Do I have anything that relates cups and cakes? I do here. Now you might be like, wait a minute, cakes is in the bottom here, and it's in the top there. No big deal. You can flip them. So cups and cakes go together. We had 2 cups for 5 cakes, right? So I make sure the 2 goes to the cups, 5 goes to the cakes. You'll notice now that dividing by cakes gets rid of it, right? Division is what happens on the bottom. And then now we have 48 times 2 cups equals cups. That's good. And 1 box times 5 equals box. So it must be a true statement. Now we just do math. What's 2 times 48? Easy. What's 50 times 2? 100. Subtract 4 because we did 2 too many twice. 96. You'll get there, don't worry. 1 box times 5. 5 boxes. How do you solve a problem like Maria?
Multiply by 3.
Multiply by 3 boxes to both sides. It gets rid of boxes here, right? And we get cups. 3 times 96 divided by 5. Let's do 3 times 96 in our heads. What's 3 times 100? 300. But we overshot by 4 3 times. See what I'm saying? We overshot by 12. So 300 minus 12. 300 minus 10 is 290. Minus 2 is 288. And then we divide that by 5. And nobody got time for that. I'm going to do that in slow motion again of how I did 3 times 96, okay? That's a hard problem. So what I did is I made an easier one. Is that going to give me the same answer as this? No way, right? That's 300. That's an estimation, right? Now, I overestimated, right? I had 4 extra groups of 3, right? This says 100 groups of 3. That's 96 groups of 3. So I had 4 extra groups of 3. 4 extra groups of 3. So I had 12 too many, right? So that's going to be 12 less than this. Subtracting 12 is hard, but subtracting 10 and then subtracting 2 is easy. What's 300 minus 10? 290. Subtract 2 more. 288. Why am I doing it this way when you can just do this, right?
Because you're smart.
Because this is hard to do in your head. Carrying ones and crap, right? It's easy to do on paper. But I can do this in my head if I learn how to think about it differently. I'm not going to make you do this. This is not Common Core nonsense, okay? But I think you'll catch on that this stuff can actually make math a lot easier. When people are able to do shit like this in their heads, it's not because they're geniuses. It's because they know how to think about it differently, okay? 3 groups of 100 minus 4 groups. This is going to get you 288. That's the same thing as this.
Mr. McDonald's keeping calculators on America's Got Talent.
Yeah, it's not because they're geniuses.
You should go and do that.
Yeah. You guys could too, eventually. If you guys really wanted to start learning how to do that, you really could. It's not that hard. It's just a different way of thinking. And it's hard to think differently, but once you do, it's okay. 4. A class contains 256 students. So in one class, we have 256 students. The ratio between boys to girls is 3 to 5. So that's 3 boys to every 5 girls. How many boys are in the class? Well, we need to convert this ratio into a fraction. Remember, ratios compare pieces to pieces. How many total pieces do we have here? 8. So we have 3 8s boys and 5 8s are girls, right? So that's going to be boys to students, right? And that's girls to students. Right? Smell what I'm stepping in from yesterday?
Yeah.
Lexi? Okay. So we have 256 students over one class. And we're going to times that by to figure out how many boys are in there. Well, we want to get X boys in one class, right? That's what we want to know. So we need to get rid of students. So I'm going to put students on the bottom. And I'd like to get boys on top. Do I have something that relates boys to students? I do. Boys to students. So 3 with the boys, 8 with the students. Notice that this gets rid of students and gets us class and gets us boys, which is what we wanted. So we must have set it up correctly. 256 times 3 boys. Let's do that in our head. Let's round that. What's 250 times 3? Can you do 250 times 3? 750, right? 25 times 3 is 75, right? So 250 times 3 is 750. What's 6 times 3?
18.
18. What is 750 plus 18? Do 750 plus 10 first. What's that? 760. We have 6 left over from the 16. 766. What's 1 class times 8? 8 classes. Now to get boys on its own, I multiply by 1 class to both sides. Multiplying by 1 is silly, but again, it gets rid of it here and rid of it there. And now I have 766 boys divided by 8 equals boys. 766 divided by 8. I don't know what that is, but I do know that I can divide it by 2, right? What's 766 divided by 2? Or Jace, how would you do it?
Oh, I have a question.
Yeah?
How did you get 766?
250 times 3 is 750. 750 plus 18. Ooh, it's an 8 here, isn't it? Good call.
Silly dude.
I said 16 instead of 18. My bad. It was 18. Good call, Jace. So 768.
That's why it was not.
Right, it was 18, right? 3 times 6 is 18. I said it and then I added 16 instead of added, yeah, right.
I think I'll also read that by 18.
768 divided by 8. That's hard to do in my head. So what I'm going to do is I'm going to divide by 2 to the top and the bottom. What's 700 divided by 2? 350. What's 60 divided by 2? 30. So I'm up to 380 now, right? What's 8 divided by 2?
4.
So I'm up to 384. So I have 384 over 4, right? Now I'm going to divide by 2 again in my head. Or maybe you'd rather do 4. Let's do 4. What's 300 divided by 4? Better question, what's 100 divided by 4? 25. So what's 300 divided by 4? 75, right? What's 80 divided by 4? 20. Close, yeah, I did too. 4 divided by 4 is 1. 96. 96 boys.
That's insane.
You just gotta break it down. And it's weird and it's different and it's crazy and it seems really hard. And it kind of is, because you gotta get used to putting those numbers in your head, but it's way easier than carrying 1s and stuff, right? Carrying 7s, oh, good lord, right? No one does that in their head. Yeah.
If you wanted to find out the girls, wouldn't you just have to times 96 by 5?
Close. Not quite. If you wanted to figure out the, there's a couple ways to do it. How can I do it? I think you need to figure out, okay, so 3/8 of the total amounts of students is boys, and that got us 96, right? So if you wanted to, you could do this and do 5/8, and you get what's left over. Or you can subtract 96 from 256 to see what's left over, right? Yeah. Good question. Good question. Glad you're here. 5. A box contains, ooh, this is a fun one. A box contains nickels, dimes, and quarters in a ratio of 2 to 3 to 5. So we have 2 nickels to every 3 dimes for every 5 quarters. There are 60 coins in the box. 60 coins in one box. The total amount in the box is 990. So that means the number of nickels, I'm going to have that be variable n, plus the number of quarters, plus the number of dimes is going to add up to, oh, I'm sorry, that's not the number. the number is going to add up to 60, right? That's number of nickels, number of quarters, number of dimes, 60 coins total, right? We have number of coins plus number of coins plus number of coins equals 60, right? To get the total, what would I do? Well, number of nickels isn't going to be adding the total, right? I've got 5 nickels, so I got 5 cents. No. If you have 5 nickels, how much cents do you have?
25.
25. How do you know that? Because nickels, the number of nickels times 0.5 gets you the number of how much it's worth, right? 5 cents. 0.05, I should say. Right? Quarters are worth 25 cents. Dimes are worth 10 cents. Now, here's the problem. We've got 3 variables and only 2 equations. Can we solve it? No. We need another equation. Look at the ratio. For every 2 nickels, there's 3 dimes and 5 quarters. So there's 10 total pieces. So the number of nickels and dimes, if I were to add those up, they'd be 5, right? Which is half. The number of nickels and dimes added together equals the quarters. The number of nickels and dimes added together equals the quarters. That's our third equation. Right? For every 2 nickels and 3 dimes, there's 5 quarters. So we know Q is equal to N plus D. So instead of writing Q, I'll write N plus D. So now I know 2N plus 2D equals 60. Divide both by 2, I get N plus D equals 30. That makes sense, right? Half the amount of coins will be the nickels and dimes, right? 5 out of the 10. N plus D equals 30. That means D equals 30 minus N. And I can take that and plug it in down here. What's for D? You with me still? Sort of. Okay. We'll go over it again at the end. Are you sort of there? I gotta give us 25%?
Yes.
I'll take 25 for now. D we said was 30 minus N. Q we said was N plus D. We still got one problem, right? We have a D in here that we don't want. We need it all to be one variable. What do we know D is equal to? 30 minus N, right?
You missed like all of them.
And now we've gotten rid of everything except for the N's. Which means, in theory, when we do all this math, we get what N equals.
That's it.
That's a lot. Okay? So let's go over what I did here. I wrote down everything that I knew. I knew that I'd have nickels, quarters, and dimes all add up to 60 total coins, right? I also knew that 5 cents times the number of nickels, plus 25 cents times the number of quarters, plus 10 cents times the number of dimes should get me my total amount, right? 2 equations wasn't enough to get the job done because I got 3 variables, so I need another equation. I was clever, and I realized the number of nickels and dimes added together is the same number of quarters. So I wrote that. See it now? So I know Q is N plus D, so I switched that out. Q is N plus D. That's 2 N's plus 2 D's equals 60. That means N plus D is 30. That makes sense. Half the number of coins is going to be nickels and dimes, right? 5 out of 10 will be, right? So N plus D is 30. I took that and plugged it in, right? Because I said D is going to be equal to 30 minus N. So I plugged it in here. Now I'm here. Did I have you up to here?
Yes.
Yes.
Okay. Do you see how I simplified my N's together, D's together? Okay. Do you see why N plus D is going to equal 30?
Kind of.
Okay.
Yes.
Half the number of coins are going to be nickels and dimes. Total number of coins 60. Half is 30. Okay. That means D is equal to 30 minus N. And I plugged it in here. I did that, so now I'm down to just two variables, N's and Q's, right? I need to get rid of Q. How do I get rid of Q? I know it's N plus D. I got that earlier, right? Now I've got D and N in here. Gotta get rid of that D. Well, I know that D is 30 minus N. And then we do math. Am I gonna make you do that right now? No. Ain't nobody got time for that. I promise if I give you one of these, it'll be much easier. Okay? The numbers will be a lot more manageable. Okay. But that's the concept. We see the concept. For real? That's amazing. You're really smart. 6. 8 slices of pizza in every box. So 8 slices, 1 box. How many boxes, X boxes, do we need to feed 23 people? 3 slices each. 3 slices for 1 person. Okay, so that's our end goal. X box, 23 people. Let's start out 8 slices, 1 box. Ooh, I want box on top. Never mind. 1 box. Box on top. All right, we'll pause for station identification. Are you with me up to here? My end goal is to have box on top and people on the bottom, so I start with box on top and slices. Now I got to get rid of slices, so I'm going to put that on the top. And I'd love to have people on the bottom, right? So I'm going to write people on the bottom. If I have something that relates slices to people, I'm good to go. Otherwise, I'd have to do multiple steps. I'm praying I can do both at once. Do I have something with slices and people in it? Yes, I do. 3 slices to 1 person. Box. Oops, sorry, box is fine. Slices and slices goes away. I get 1 box times 3. That's 3 boxes. X box. Illuminati confirmed. 8 times 1 people. 8 people. Ah. How do you solve the problem in Maria? Times by 23 people. People and people will go away. Which is the whole point of math, I think, to make people go away.
Wow.
Right? All that's gone now. And I have 23 times 3 divided by 8. 23 times 3, what's that? 69. Divided by 8, nobody got time for that. It doesn't divide evenly. So you need 69 eighths boxes. Now, if we're going to answer that for real, we can have 69 eighths of a box. What is that approximate? Well, I know 64 is 8 times 8. So that's a little bit more than 8 boxes. Can we get 8.5 boxes? No. So we got 8.5. Yeah, right? I mean, for this real world problem, right? You know, at the end of the day, we're doing math for a reason, right? That's great, but who cares, right? That's the real answer, right? 7. Man that's tall. We've done that one before. Do we know how to set it up?
Yeah.
It's a proportion. 6 foot tall object over its shadow equals the other object over its shadow. Solve for x. 8. Convert gallons to tablespoons if there are 4 quarts in each gallon. All right, here we go. Our goal is to get gallons to tablespoons, which means we're trying to say how many tablespoons are in 2 gallons, right? That's what we want. I know there are 4 quarts in each gallon. 4 quarts, 1 gallon. I know there are 4 cups in each quart. 4 cups in 1 quart. And 16 tablespoons in 1 cup. All right, so we want to get gallons on top and tablespoons on the bottom, so we should probably start with one of those, right? Let's start with gallons on top. So I'm going to take this one, and I'm going to write 1 gallon over 4 quarts. I put it on top because I'd rather it be on top, right? I want to get rid of quarts, so quarts has to go here. I prefer to get tablespoons. Do I have anything with quarts and tablespoons in it? I have quarts and cups. Tablespoons, no, I don't. So I'm just going to do quarts here, but I got to get rid I'm getting rid of quarts. I'm going to keep the gallons. So what do I have with quarts in it? Anything? I wouldn't want to use this one again, because if I put gallons here, I get everything gone. That's no good. What do I have with quarts in it? This one. So I'm going to get cups in the bottom, which is not what I want, but like it's a necessary evil. Right? I did that so I could do this. Right? Now I've got gallons and cups. I want to keep gallons. I want to get rid of cups. So where do I put cups? Top or bottom?
Bottom.
Not bottom, because that's going to be cup squared when I multiply that. You've invented a whole new kind of cup. We want cups on the top, so this goes away. We need something with cups and preferably tablespoons, because we don't have any units down here, right? Do we have something with cups and tablespoons? We do. 16 tablespoons in 1 cup. And now all we're left with is gallons to gallons and tablespoons. So we must have set it up right. I don't have to think about what's in what and all this crap. I just make units go away. The best part about math is making things go away.
I know, right?
So now we have 1 gallon times 1 times 1. What's that? 1 gallon.
Say 2 gallons.
Tablespoons. X tablespoons. TBS.
4 times 4 is 60.
Turner Broadcasting System. I don't know. TBS. Okay. 4 times 4 times 16 tablespoons. What's 4 times 16?
6.
4 times 16
64. That's 64. What's 64 times 4? Pause. Let's do 60 times 4 in our head. What's that?
280.
Try again. 60 times 4.
240.
240. What's 4 times 4?
16.
Don't you dare. 4 times 4 is 16. 240 plus 16. 256.
Why?
And that's TBS's. How do you solve a problem like Maria? How about we flip them both to make it easier? As long as you do to both sides, it's algebra, right? Otherwise, it's child abuse.
256 tablespoons.
Times by 2 gallons to both sides. Makes all of that go away because it perfectly matches. Only makes gallons go away. What's 2 times 256 divided by 1? Well, we can ignore that, right? 2 times 256. What's 2 times 250? 500. What's 2 times 6? 12, so it's 512. That's a lot of tablespoons.
I'll try it.
That's like cooking at my house when I lost half my stuff in the divorce. All right.
Oh.
Gotta measure out cups. All we got is tablespoons. All right.
That's
got a
huge.
divorce?
Divorce is on 3.
I didn't get divorced. I almost got married though.
I
didn't
remember
break
that
up.
story.
I had to break up with it.
I
Didn't
know
love
that
it.
story.
You got 10 years.
You had too much fun last night.
You think Ariana? No. Who was it that broke up with their boyfriend after almost 9 years? Oh, it was Selena Gomez. She hasn't gotten nearly as bad as me.
No, that's
10
not.
years.
Oops.
All right. And she was fabulously wealthy, and now I'm poor.
Yay.
But I didn't love her. Good person, but did not love her.
Good person did not.
Yeah, it happens, guys. All right.
Video games.
9. Here we go. We've got 9 boxes. Okay, and we want to convert it to pencils. So 9 boxes means how many pencils?
100 pencils.
If every box contains 20 packs, so 1 box has 20 packs.
40 packs.
And each pack contains 12 pencils. So 1 pack, 12 pencils.
So you just do 12.
That's the stuff I have to work with. That's our end goal. We want boxes on top and pencils on the bottom. How about we start with boxes on top here? You can start with the other if you wanted. Do I want packs? No, I gotta get rid of packs, right? So I'm gonna put packs on the top. So we do packs divided by packs and get 1, right, goes away. And I need, preferably, to have pencils on the bottom. Do I have anything with packs and pencils?
Yeah.
I do. So now I get boxes and pencils. So I'm good. What's 1 box times 1? 1 box. What's 20 times 12 pencils? Guys, what's 20 times 10? 200. What's 20 times 2? 40, so 240. Ooh, we gotta flip them, right? Guys, word of advice, don't ever write your X on the bottom, okay? Right. So now we gotta flip them.
That means Smiley's gonna put an X on the bottom.
It'll come back to bite you later. There's like a moral there.
It's like right here.
Like
Don't
last
put your X's on the bottom.
I'm sorry.
It'll come back to bite you later. Yikes.
Uh,
Times 9 boxes to get X on its own. Boxes and boxes goes away. 9 boxes and 9 boxes go away. We get 9 times 240 divided by 1. Oh no, that's hard. What's 240 times 10? 2,400. Subtract 240 because we went 240 too much. 2,400 minus 240. That's going to be 2,160. That's a lot of pencils.
That's insane.
10. How many liters of 80% alcohol solution? Things just got PG. Should be added to 4 liters of 25% alcohol solution. Guys, this is a real world problem. You might have to answer this weekend. Okay? How many liters of 80% alcohol solution? So volume 1 times 80%.
How much alcohol did you drink?
Plus 4 liters, 25% alcohol.
This is how much was in my Kool-Aid.
Now, here's the problem. We have 2 variables, only 1 equation. What do we know about the volumes? Volume 1 plus 4 is going to equal volume 2. So I can write it like this. Does everybody see why volume 1 plus 4 equals volume 2? Remember, these 2 volumes are going to add together to make the total volume, right? So these 2 added together give me volume 2. So I switch that out. Now I have 1 type of variable with 1 equation. I can solve that. Notice I can multiply everything by 100, right? And it'll make the hundreds go away. So let's just do that. Now I distribute. Are you following along?
Yes, sir.
Again, watching helps here.
A little bit.
If I subtract 50V from this side, I get 30V. And if I subtract 100 from this side, I get 100. So V1 is going to be 100 over 30, which means it's 10 over 3 when you simplify. So about 3 1/3 liters, right?
I want to put that in my Kool-Aid.
What?
You write too fast.
That's why you shouldn't write.
What?
Look at all the newbies writing stuff down. I'll give this to you at the end. I'll give it to you.
Yeah, but we got a problem on time.
What?
My cup broke.
I'm sorry. It broke or you broke it?
I kind of stopped now. Sorry.
1 tier.
Where can I put it at? I don't want to kill any turtle.
You can put it up there. It's still usable, right?
No.
Oh no. The turtle's already dead, my dude.
Oh well. Stuff happens, you know.
I would highly encourage you to watch the video tonight to review.
Is Lennon still alive?
Yes, he's right there. All right, 10% acid solution and a 40% acid solution. We're going to add them together to make 5 liters of a 15% solution. So this is what we want, 15% of 5 liters. We know we're adding together a 10% solution of an unknown volume with a 40% solution of an unknown volume. What do you know about the volumes?
They add together to make the answer.
Good job, Parker.
Right? Are you with me?
Yes.
Yeah.
So I'm going to take that and plug it in for V2. You still with me, Lexi? Whenever we plug stuff in, we wrap it in parentheses. You can explain the joke to them later, guys. I switched it out. Right? Whenever you plug it in, no matter where you plug it in, no matter what you're doing, make sure you wrap it in parentheses. Prevents a lot of little mistakes. Now we can times everything by 100 to get rid of those hundreds. Honestly, I just never write the hundreds, but I want you guys to see why I don't. It's because when you times everything by 100, they go away, right? Again, everything gets multiplied by 100 when you multiply, right? Not just both sides, but every term, right? Now we get 40 times 5. What's 5 times 4?
50.
Times 10. 4 times 5 is 20, times 10 is 200. That's okay, it happens. I believed you too. I was like, yeah, he's right. He's saying it with such courage and confidence. I'm like, yeah. 5 times 15. What's 5 times 10?
50.
What's 5 times 5?
25.
So this is 75. 25, the only thing funnier than 24. 10v1 minus 40v1. They're on the same side, so we're not going to add them together, right? We just put them together. It's negative 30v1. And if I subtract 200, what's 75 minus 200? Negative 125. Divide by 30. They aren't negative anymore. That's good, because we can't add negative volume, right? We divide by 30. It goes into it about 4 times, right? Or I'll take 125 divided by 30, and then simplify that down to 25 over 6, because they divide both by 5. A little bit over 4, right? And that's volume 1, right? So solution A, we need 25/6. To find solution B, we got to go back and plug that in, right?
Yeah.
Don't write them.
I give up.
That's it.
Alan Smike, he does it right.
Who would like copies of this? You guys.
Just for like the whole
Can I
class.
get a drink?
Oh,
Yeah.
you got-
Can I get a drink? Can I get a drink?
No comment.
Hey Doug.
Sure? Okay. Howdy.
Shut up, Coacher.
Shut up, I'm gonna entertain you.
Can I get a drink?
Tell me a joke then. Your wife.
Oh no, Trump, close the world.
Where did you get that?
Honey, look at my post.
Hey, it's kind of warm. When are we gonna paint your room?
Close the world.
We can't close yet. Not seafood. It's seafood.
Mr. Mac, why do you have that?
Sloffer made it for me. Actually, he didn't make it for me. He made it and then gave it to me. I don't.
Can I put it in my
He gives me
wallet?
things. What?
I take it, put it in my
The,
He hit my mailbox, so he owed
He
me.
hit your mailbox? That was your mailbox?
And my sister's.
Did you replace it?
Yes.
Okay.
Wait, who
got
did?
it.
It was my mailbox and my sister's.
Did you get a nicer one after it was done? Win-win. Win-win, baby.
Right.
Just so we know, this is not for a grade, so don't turn this in. This is for your health. Yeah.
no.
I like that guy.
Me too. Yeah, guys, look, I got a card for my students the other day. For Hazelwood.
That is awesome.
Look at that, they found it.
We're still streaming.
You're still live.
Oh yeah.
He
we're live.
is.
I probably need to make this like.
You need to put on your live
Censor.
PG. Oh God.
Oh, trust me.
Yeah, I'll get you.
Some of
Still
the
streaming.
I'm gonna grab these copies now. Again, it's not homework, guys. You don't need to turn it in. That's why I give you copies. It'd be silly to make a copy and then turn it in. Right?
Can I take this after school?
Any warm-ups you have in the last 2 weeks? And
Let's just go
homework.
outside.
Okay.
Like this.
Wait a minute, homework?
Standing there.
I'll want this so on the stage trees.
Yeah, for help. Wait, you know where you use those cups? Other people?
No, just
You'll get you.
Nice pants. Like velvet. Velvet pants. Fuzzy.
That's our nice gaming headset.
Yeah, it does.
You're a nice kid.
So again,
Shut up,
no
Tucker.
penalty for taking it. Right? I will take it.
I gotta see.
I'll throw hot mashed potatoes at you. Tucker, I'll hit you in the face with some hot. Throw some hot mashed potatoes.
Coming to you live.
I think you're still streaming.
Is it?
You're still streaming. Yeah, it's on.